Hello and welcome to the BS Academy. So recently IIT Bombay has changed their syllabus a little bit to the each branches. So according to the new syllabus, we have made these charts in our best possible ways, and these charts basically give you an idea how to prepare your own charts, because ultimately you have to make your own charts of every subject, and after that you will get that confidence. So basically these charts will give you the ideas and perfect information after referring all the reference books. Now this is the fourth subject of the GATE Mechanical 2021. The subject name is IM and OR, or you can say that the Industrial Engineering. For this subject we have made total 4 charts in which we'll cover all the concepts and the syllabus for the Industrial Engineering subject. Now in the first chart of the Industrial Engineering subject will include the forecasting process as well as the assembly line balancing, and the last topic is queuing theory. Now let's begin with the first one, which is forecasting. Before that, if you are new to our academy, then please subscribe for the coming videos, and the links for the short notes which are in description box. The first one, which is forecasting. Forecasting estimates the demand of future and the lead of demand in the future. Then first one is supply chain management. Is there in that the chain will be like supplier, then manufacturer, then warehouse, then distributors, then retailers, then customers. Then after the types of forecasting, first one is on the basis of time. There are 3 types: short-term forecasting, which is less than 1 year, then long-term forecasting, which is for greater than 3 year, and the medium-term forecasting, which is for 1 to 3 year. Then after there is the note there, short-term forecasting is for training related activities, and demand will be function of something like there are 5 types of demand. First one is stable demand, then cyclic demand, then seasonal demand, then fourth one is residual demand, and the last one is trending demand. Then on the basis of availability of the data, there are 2 types. First one is qualitative forecasting and the second one is quantitative type of forecasting. So for the qualitative forecasting there are 4 types. First one is group averaging, then after the group consensus, then Lcm Method, and the last one is market survey. Then the second one is quantitative type of forecasting. This is also known as time series forecasting. Now the 5 types are there. First one is simple moving average or rolling average or time horizontal method. Then the second one is weighted moving average method or rainfall forecasting method. Then third one is simple exponential smoothing method, and fourth one is regression method. The fifth one is least square method. Now for the simple moving average method, Fi is equal to sigma di by n, and for weighted moving average method, Fi is equal to sigma wi into di upon sigma wn. Then equation, then for the regression method, equation will be like sigma yt is equal to a into sigma t plus b into sigma t square, and a is equal to sigma y by n minus sigma x upon n. Then b is equal to n into sigma xy upon n into sigma x square minus sigma x into sigma y upon sigma x square. Then third one is simple exponential method. For this method the equation will be like ft plus 1 is equal to alpha into dt plus 1 minus alpha into ft, where you can say that alpha is equal to smoothing constant and value of alpha is equal to 2 by n plus 1, and f2 is equal to alpha into d1 plus 1 minus alpha into f1. Here remember that the value of alpha should always in between 0 to 1. Then there are 2 cases are there. If f2 is equal to f1, then alpha is equal to 0 and stable demand is there. Then ft plus 1 is equal to dt, then f2 is equal to d1, then alpha is equal to 1. So the error is d1 minus f1 or dt minus ft. Then the last method is least square method. For this method, a is equal to sigma y by n, then b is equal to sigma xy by sigma x square, and y is equal to a plus bx. So these are the 5 methods. From these mainly the questions were asked. Now the second topic is assembly line balancing. In this, first one is manufacturing point of view, in which with the critical time is based on the maximum amount of the product, and the second topic is time point of view, in which the critical time will be taken as the cycle time or maximum time for the cycle. Then cycle time Ct is equal to greater than station time. Always remember that cycle time Ct is always greater than or equal to station time. Then line efficiency L is equal to sigma St by Ct into N, and balance delay Bd is equal to 1 minus Le. Then Bd is also equal to sigma It upon Ct into N, where It is equal to ideal time and Ct is equal to cycle time. Then smoothing index Si is equal to under root sigma I is equal to 1 to N Ct minus St of I square, and Si should be as low as possible. Then critical time or bottleneck time eta mean is equal to sigma St by Ct. Then for L is equal to 100%, Bd is equal to 0%, and eta is minimum. Note that Le is always in the percentage. Then there is one example there which was asked in the GATE examination. Now the third topic is queuing theory. In that, first point is lambda, which is equal to customer arrival rate, and it follows the Poisson's distribution. P of t is equal to lambda t raised to n into e raised to minus lambda t by n factorial. Then Pt means for the second one is mu is equal to customer service rate, which is assumed to be exponential distribution. The equation for that, P of t is equal to 1 minus e raised to minus mu t. Then the third one is system and calling population. System is the place or facility where customers arrive in the order to get the service, and its capacity may be finite or infinite. Then note there, lambda less than mu is the condition of steady state finite queue. Then fourth one is customer attitude. There are three types of attitude there. First one is choky, second one is barking, and third one is reneging. In the choking, the customer keep changing the queue. In the barking, customer leave the queue after waiting for long time. And in the reneging, customer join the queue for the short duration time, and after receiving the service, customers leave the group. Then candle notation is there. Hgem Bgem C is equal to Dgem Egem F, where A is equal to probability distribution for arrival pattern. Then B is equal to probability distribution for service pattern. Then C is equal to number of service in the system. D is equal to service rule or service model. Then E is equal to size or capacity of the system, and F is equal to size or capacity of the calling population, or you can say that input source. Then after expected waiting time in the system, Ws is equal to 1 upon mu minus lambda. Then expected waiting time in the queue is equal to Wq is equal to lambda by mu into mu minus lambda, and Wq is equal to rho into Ws. Then there is one other point is there. Then traffic intensity, or you can say that the system utilization or average utilization or channel efficiency or the clearing ratio will all be same as the rho, and rho is equal to lambda by mu. So the rho is equal to 70%, means 70% of time is waiting time. Then if the system is idle, then probability of 0 customer in the system, P0 is equal to 1 minus rho, and n customer in the system is given by Pn is equal to rho raised to n into P0, where 0 less than or equal to n less than or equal to infinity. Then note there, sigma n equal to 0 to infinity, Pn is equal to 1. Then fourth one is length of the system, Ls or expected number of units in the system. Ls is equal to lambda upon mu minus lambda, and Ls is equal to lambda into Ws. Then expected number of units in the length of the queue, Lq is equal to lambda square upon mu into mu minus lambda, and Lq is also equal to lambda upon mu into Ls, and Lq is equal to rho into Ls. Then Lq is equal to lambda into Wq. Also Lq is equal to rho square upon 1 minus rho. Then variance V is equal to lambda into mu upon lambda minus mu square, then average length of non-MPQ L NEQ is equal to mu upon mu minus lambda. Then 10th one is Little's law for stable system. LQ is equal to lambda into WQ is equal to rho into LS, and LS is equal to lambda into WS. So this is all about the first chart of the industrial engineering, in which we have covered the first one is forecasting methods, then after the second one is assembly line balancing, and at the last queuing theory is there. So if you like this video, please do like and subscribe to the BS Academy and press the bell icon for the upcoming video. If it is useful for your other friends, then please share this video who is preparing for the GATE examination 2021. Thank you so much. Hello and welcome to the BS Academy. Now this is the second chart of the IM and OR, in which will include the project management as well as the linear programming problems, and at the end of the video the assignment problems are there. Let's begin with the first one, which is project management. Now in that there are three charts are there. First one is the bar chart, then after the milestone chart, and the third one is PERT or CPM. In the bar chart you can see the diagram here. Then it is the simplest project management technique, and it is used for smaller projects. Then activities are represented by the horizontal bar, and here not applicable for the complex type of work, and interdependency is not established in the bar chart. Then after the second one is milestone chart. It is the improvement over bar chart, in which at any point of the time it gives the detail about how much fraction of activities are completed. Then third one is PERT and CPM. We will discuss about it later. Then there is note for the equation of the PERT. Here T is equal to T0 plus 4Tm plus Tp by 6, and Tp greater than Tm greater than T0, where T0 is equal to optimistic time, then Tp is equal to pessimistic time, and Tm is equal to most likely time. Then after the difference between the PERT and CPM. So first one is for PERT, the full form is Program Evolution Revenue Technique, and for CPM, Critical Path Method. Now if we talk about the PERT system, in that PERT is event oriented, then control device, then fourth one is applied on new type of project, then project data are not available, then sixth one is based upon the probabilistic approach, and the last one is uncertainty of the results in the PERT system. Then coming towards the CPM system, in that it is critical path method, then activity oriented method, then planning device, then repetitive type of project, then data are available for this type of system, and deterministic approach. Then after the seventh one is certain results. Now there are definitions for the activity and the event. First one is for activity. It is used for to complete a project within minimum time with minimum cost. It is necessary to divide a project into subparts. Then these subparts are called as activities, and activities consumes resources and time. Then event, it is an instantaneous phenomena, and it doesn't consume any resource or time. It can be represented by various symbols like circle, triangle, operation, and the nodes. Then after there are some rules for making the diagrams. First one is, in the forward pass the time will be maximum, and in the backward pass the time will be minimum. Then first rule is there, two activities cannot have same starting and ending point. Then after the second one is, cyclic concepts should be always avoided in making the diagram, and third one is, dangling should be avoided. It means not one open end in the middle. So these are some rules. Then after here, EST stands for earliest start time, then EFT stands for earlier finished time. Then after LST stands for late start time and LFT stands for late finish time. Then here for slack calculation, if we take an example like two activities, here 1, 2 and 3, 4, then here first one is head event slack is equal to LFT minus EFT, then head event slack is equal to 4 minus 3 is equal to 1, then tail event slack LST minus EST, TES is equal to 2 minus 1 is equal to 1. Then after critical path, here for networks critical path is equal to maximum time plus network, then for project minimum time plus project. Then one note is there, the slack is always 0 for the critical path, hence you can say that Ft is equal to Ff is equal to Fi is 0 for the critical path. Z is equal to Ts minus T upon sigma. Then here some equations for the variance and the standard deviation as well as the range of the project. So first one is for variance, V is equal to sigma square, which is equal to Tp minus T naught by 6 square. Then for sigma Cp, which is standard deviation of critical path, the equation will be like under root sigma Cp square. Then the range of a project, R is equal to T plus or minus 3 into sigma Cp. Then there is a note there, overall project duration follows the normal distribution curve, then Gaussian distribution curve and then bell shape curve. Here one hem symmetrical curve is also known as the bell shape curve. In IM and OR subject, the examples are very important because based on the example you can understand the different concepts very easily. Now here is the first example for the finding the value of critical time and the critical path as well as the standard deviation of critical path. Then the third example is find the value of free float for activity 4 to 6 and the project duration. Then network diagram is given in this example. So here first one is HES is equal to 10 minus 10 is equal to 0, then TES is equal to 6 minus 2 is equal to 4. These values of 10 and 2 are given in the diagram. Then after Ft is equal to LFT minus EST minus Tij, which is equal to 10 minus 2 minus 4 is equal to 4. Then Ff is equal to Ft minus HES, then Fi is equal to Ff minus TES. Here Ft stands for total float, then Ff stands for free float and Fi stands for independent float. In the example mainly you have to find these three floats. Then the fourth example is for finding the normal distribution value. Then here Z and P percentage values are given in the question. Then you have to use the equation of Z is equal to Ts minus Te by sigma Cp. Then the value of Ts will be 65.76. Then second one is P is equal to 35%, then Ts will be 58.25. You can understand this example in this way that for 90% probability the work is completed in 65.75 unit at a workstation, and for 35% probability the TS means the time at the station is 58.25. Then for finding the value of float, Ft is equal to LFT minus EST minus Tij, then Ff is equal to Ft minus HES, then Ft minus LFT minus EFT, then Fi is equal to Ft minus HES minus TES, and Ff minus LST minus EST, which is also equal to Fi. So from this chapter mainly the questions were asked based on this equation. Now there is one more example which was asked in the GATE example 2019. So you can calculate this example. Here in this example you have to use the equation of Z is equal to x minus mu by sigma. Then you have to also use the concept of 6 sigma. For that, the probability less than or equal to minus 2 to 1, you have to divide into two parts, minus 2 to 0, then 0 to 1. So the probability at the end will be 81.85%. Then after the next topic is crashing. In the crashing process, cost reduced by reducing the time, and crashing always done on the critical path. Due to the crashing, the TC will always decrease. Here TC means total cost, and direct cost will be increase and indirect cost will be decrease. Then after, in critical path activity, having minimum slope should be crashed first. This you have to remember because you have to use this in the questions. Then after, direct cost and indirect cost are there. Then you can see the diagram here for the direct cost and example like. Then after, cost slope is equal to Cc minus Cn upon Tn minus Tc, where Cc is equal to crash cost, then Cn is equal to normal cost, then Tn is equal to normal time, and Tc is equal to crash time. Then for the indirect cost, it is the cost not directly involved in the completion of an activity but is required for safe and timely completion of project. Then the curve is there for the indirect cost. Here Tc is equal to minimum activity duration to which an activity can be compressed by increasing the resources and hence by increasing the direct cost. Here Tc is equal to dc plus slope of the activities. You can check the example here. This diagram is very important for the exam, in which the Tc, IDC and DC were represented. Now coming towards the linear programming problem. So the requirements are to find the objective in the terms of function, then constraint or subjective equation, then LPP is used for optimization of limited resources when there are alternative solutions possible for the given problem. Then all the constraints should be linear, and rules in linear programming are: first one is law of certainty, then after the law of proportionality, then the third one is law of addition, or you can say that the summation, then the fourth one is law of continuity, or you can say that the divisibility. Then after, there are types of solutions are there. First one is unique solution, in which the number of zeros in Cj minus Zj row is equal to the number of basic variables. Then for the second one, multiple solutions, in which number of zeros in Cj minus Zj row is greater than number of basic variable. Then third one is unbounded solution, in which if there is no least minimum ratio, then it is called as the unbalanced solution, or you can say that the unbounded solution. Then after, fourth one is degenerated solution. Tie in the minimum ratio is also covered in the degenerated solution. Then if one of the basic variable RHF is 0 at optimal point, then it is called as degenerated solution. Here you can see the example there, and here note that degenerated solution always on the axis. Then the last one is no solution, for which the m remains positive. Here you can see the first example, in which binding constraint equation is given like maximum z is equal to 3x1 plus 9x2 subjected to these values. Then you have to find the zc and zd. So first of all, you have to draw the diagram based on the values are given. Then after, the area under the curve, it gives you the points of c and d. Then put the values in the equation of z is equal to 3x1 plus 9x2. So there are 2 points are zc and zd. Then after, the second example is for maximum z equal to 3x1 plus 2x2 and x1 less than or equal to 4. Then you can make the diagram like this one, and the values are 18, 18, 12 and 18. Here note that redundant constraint equation, in which the constraint which doesn't becomes the part of boundary making feasible region is called as the redundant constraint equation. then inclusion or exclusion of such constraint doesn't have any effect of final optimal solution of the given problem. Here you can see in the diagram that the upper curve is known as the redundant constraint because it doesn't affect on the final solution. Here the third example is there for the degenerated solution, in which you can see that the solution is on the axis. Fourth example is for no solution. Then there is one other example for the duality concept. From that, the questions were asked in the GATE 2019. Then the final topic is assignment problem, and it is normally used in the job sequencing process. So here the Hungarian method, or you can say that the Hungarian algorithm or degenerate solution or square matrix, for that one method is there which is used in the assignment problem. Let's see Hungarian method by one example here. If there is a matrix is given here of 3 by 4, then first you have to add one dummy column here in the first step. Then make the first step is row minimization. In that you have to deduct the minimum row from all the rows. Then after the column minimization process, in which you have to deduct or minimize the minimum column from all the columns. And then after, in the third step, you have to calculate the number of zeros is equal to the number of row or column. If not possible, then minimum element from all the elements, select that element and subtract it from all the other elements and add it at the intersection of the lines. Then here 1 is minimum element, so we'll deduct it from all the above element and add it at the intersection. Here 2 zeros are intersection, so at 2 places we add the value of 1. Then after, once again calculate the number of zeros which is equal to number of rows or columns, then the answer is optimum. Similarly, for the maximization problem, first you have to minimize the maximum value from all the other elements, and then after the problem will be like the minimization as the above. So this is all about the second chart of the assignment problem, in which we have briefly discussed all the important terms and important formulas. If you like this video, please do like and subscribe to the BS Academy and press the bell icon for the upcoming video. If it is useful for your other friends, then please share this video who is preparing for the GATE examination 2021. Thank you so much. Hello and welcome to the BS Academy. Now this is the third chart of the subject IM and OR, in which will include the transportation problem as well as the plant layout, and that after the job sequencing. At the end, the quality engineering is there. Let's begin with the first one, which is transportation problems. We are providing the short notes for the different subjects of the mechanical engineering for GATE 2021. So if you are new to our channel, then please subscribe for the upcoming videos. And till now we have completed the 3 subjects. The links for that videos are in description box. In the transportation problems, or you can say that the transportation models, first question in your mind that what is the need for these models. As you all know, LPP, which is linear programming problems, is dealing with the issue of shipping commodities from multiple sources to multiple destinations. So the objective of the transportation models are to determine the shipping schedule that minimizes the total shipping cost while satisfying supply and demand constraints. And here TM is a comparative tool in the business decision making. Then after, main applications of the transportation models are for the location decisions, then after the production planning, then capacity planning and the transshipment. Then there are major assumptions which are taken in the transportation models. First one is items are homogeneous. Then second one is shipping cost per unit is same. Then the third one is only one route is from place of the shipment to the destination. Now there are some notes which are very important for the GATE examination point of view. First one is the number of decision variable which is equal to m cross n, and also you can say that the number of dependent point. Then second note is if total demand is not equal to total supply, then number of demand is equal to m. Then third one is number of supply point, or you can say that the number of constraint or number of basic variable all is equal to m plus n minus 1. Here the fourth note is there. Then fourth one is number of basic variable plus number of non-basic variable is equal to number of dependent variables. Then fifth one is for non-degenerate problem, allocated cell is equal to m plus n minus 1, where allocated cell is equal to number of basic cells. Then after for degenerate problems, number of basic cell is not equal to m plus n minus 1. Then after Modi method is used for basic feasible solution of non-degenerate problems. Mostly in every example, Modi method is used. Then after in degeneracy, you have to add the epsilon or some values at the non-basic cell having the least cost and which do not make the closed loop, that you have to remember. Then after, if demand is not equal to the supply, then add dummy row or the dummy column, and penalty is equal to difference between two minimum cost. Then the last note is for the Lcm method, for two equal least cost cells, you have to give the priority the cell having the more demand. Then there are 5 methods for the transportation models. It can be classified in two ways. First, for the initial basic feasible solution, there are 3 methods are there. First one is northwest corner method. Then after, second one is least cost method, and the third one is the Vogel's approximation method. Then for optimal solution, there are 2 methods are there. First one is the Modi method and the second one is stepping stone method. And due to we are making the videos of short notes only, we are not here explaining the methods in detail. So if you want to learn this method, then the videos are available in the YouTube, you can search out there. Then coming towards the next chapter, which is plant layout. Basically there are 4 types of the plant layout. First one is product or line layout, then after the process layout, then the fixed position layout, and the last one is cellular layout. Now for the first layout, which is product or line layout, the efficiency will be more, then high quantity, then mass production, then less waiting time, and PPC will be easy for this layout. Then efficiency is also, you can say here the line efficiency is there. Then in the second layout, which is the process layout or functional layout, the variety of the products is more in this layout. Then non-standard products, then after automation is not possible, then efficiency is lower than the product layout. Then after high skilled manpower is required, then PPC is very difficult for this layout. Then third layout is fixed position layout. Here the product is made at the place or the location of the requirement, and the examples are like wagons, boilers, ship, big weapons, aircrafts, etc. Then the fourth layout is cellular layout. It includes the FMS. Here FMS stands for Flexible Manufacturing System, and cellular layout is the building block of the FMS. In this layout, batch production can be done. Cellular layout, you can say that it is the combination of product layout and the process layout, because by this layout you can get the more line efficiency as well as more variety of products. Then after, lean manufacturing system. Before that, we have completed 6 chapters of IM and OR. The link for that videos are in description box. Now it is used for reducing the wastage of the material, then transportation as well as inventory and the machining delay time. Then after in this process, JIT means just-in-time process which used, and it is pull system there. Then Kanban system is also used for feedback need of inventory, and Can means visual and Ban means signal. Then after the visuals are Pkanban and signals are Ckanban also called. Now there are two types of systems. First one is pull system and second one is push system. In the pull systems, after the requirement of the customer, the orders are placed, and in the push system, without the requirement of the customers, the products are pushed in the market. And note that the JIT is pull system is there because when the requirement of the customers are there, then just in time the process is used and the manufacturing is done. One note is there which is important for the examination. If we talk about the quantity point of view, then job, then after batch production, then after mass production, and then after the continuous production, the quantity will increase. And if we talk about the variety of the products, then continuous products, then mass products, then batch products, and then after the job products, the variety will increase. Then the full form of craft is computerized relative allocation of facility technique, and full form of LDAPT is automated layout design problem techniques. Then after the fourth one is the facility layout technique chart is LDAPT and it is used for relationship. These four notes were asked in the GATE examination in the questions like the full form of the respective terms. Then here the important term is there. BEA means the break-even analysis. In that first one is BEP means break-even point. For break-even analysis, the graph is here. You can see that there are FC, TVC, TC and TRC are represented. So when the total cost and total revenue cost are intersect each other, then the point is known as the QBEP means break-even point. At break-even point, no loss, no profit situation is there. After that, the profit will generate. Here one example is also there for finding the value of BEP. See that y1 is 100 plus 2x and y2 is 200 plus x. Then draw the diagram. Then at x is equal to 100, the line 1 and 2 are intersect each other. Then the point x is equal to 100 is known as the break-even point, and at BEP total cost is equal to total revenue cost. Then after some equations are there. First one is contribution is equal to P minus VC. Then contribution of margin QX is equal to TRC minus TVC. Then marginal cost MC is equal to PQ minus VQ. Then CMR is equal to TRC minus TVC upon TRC. Then CMR is also equal to PQX minus VQX upon PQX. Then after the quantity Q is equal to FC upon P minus VC, where Q at BEP, and CMR is equal to 1 minus VC upon P. Then sixth one is break-even quantity. BES means break-even sales, which is equal to P into Q at BEP, and BES is also equal to FC upon 1 minus VC by P. Then profit is equal to TRC minus TC, which is equal to PQ minus FC plus Q into VC, and profit is also equal to minus FC plus P minus VC into QX. Then for profit, QX should greater than QBEP and TRC should greater than TC. Then after some equation for the financial evaluation of project, and the objective of the financial evaluation of project is potential for earning and impact of an inflation, then effect of risk. first one is the concept of fixed deposit. For that, the equation will be like f is equal to p into 1 plus I raised to n, where f is equal to future value, p is equal to present value, n is equal to number of year, and I is equal to interest rate per year. Then corresponding factor for single payment is equal to 1 plus I raised to n gem 1. Then present value factor for future payment is equal to 1 upon 1 plus I raised to n. Then after recurring deposit RD, for that f is equal to a into 1 plus I raised to n minus 1 upon I. Then a is equal to f into I upon 1 plus I raised to n minus 1, where corresponding factor is equal to 1 plus I raised to n minus 1. And annuity or equal payment series, a is equal to, the equation will be like f into I upon 1 plus I raised to n minus 1. Then sinking factor or deficit factor is equal to 1 upon 1 plus I raised to n minus 1. And the last one is the loan concept, in which p is equal to a into 1 plus I raised to n, where n is negative, and divided by I. Then a is equal to p into I upon 1 minus 1 plus I raised to minus n. Then capital recovery factor is equal to I upon 1 minus 1 plus I raised to minus n. Then coming towards the job sequencing, in this process, the Gantt chart or Johnson's algorithm is very important for the examination. So there are mainly 3 to 4 types of questions were asked from this chapter. The second type of questions, which is based on the Jackson's algorithm. For that, two conditions are there. First one is minimum of m1 is greater than that of maximum of m2, and the other one is minimum of m3 greater than or equal to maximum of m2. From these two conditions, if one of the conditions is satisfied, then you can use the Jackson's algorithm. Then after n job 1 machine questions, there are 3 methods are there. First one is SPT, then EDD, and the last one is CR method. Here SPT stands for shortest processing time, then EDD stands for earliest due date rule, and CR stands for critical ratio. Here note that in the EDD, the jobs will be sequenced in increasing order of the due date, and for critical ratio, the CR is equal to due date minus today's date upon days needed to complete the work or complete the job, which is equal to time remaining upon the work remaining. And CR greater than 1, then the job is ahead of schedule, then CR is equal to 1, then job is on the schedule, and CR less than 1, then job is behind the schedule. So these are some notes there. Then least slack is equal to due date minus processing time. Some important terms are there. First one is the job flow time. We can say that the time from starting time to the completing time of the job. Then second one is the average JFT, means total JFT divided by the number of job. Then MOS is equal to PQX minus PQ at BAP, then divided by PQX, and the average number of job in the system, which is equal to total job flow time upon MST, or you can say that the elapsed time. Here MST stands for max burn time. Then after, the lateness is equal to positive, which means positive is a task will complete after the due date, and if the negative lateness is there, then before due date is there, which is desirable for the process or for the job. Then after, the last chapter is quality engineering. From this chapter, Mostly the 1 mark questions will be asked in the CAT examination. First one is value engineering. It is a function-oriented systematic team approach and study, and it provides the value in product or service. Then value is equal to function per post, or you can say that the utility per post. Then value engineering is a productive approach and done before the product formation. Then the second one is the value analysis, and after production value addition is known as the value analysis. Here it is the reactive approach and it is done in the post-production process. Then total quality management TQM is there. It is based on the top management, then fully involved, then strong customer orientation, then after systematic problem solving approach. And then the QFD is there, quality function deployment. Then premium customer is there, then fulfill customers requirements and voice of customers into design specification. Then after methods of identify the critical customer attributes to create a specific link between the customer attributes and the design specification. Then the meaning of Kaizen is continuous improvement. Then after the most important topic is there, which is Six Sigma, and the diagram for this topic you can see here. Then the equation of f of x is equal to 1 upon sigma into under root 2 pi into e raised to minus 1 upon z into x minus mu by sigma square. Then for plus or minus sigma, the percentage will be like 68%, then plus or minus 2 sigma, percentage will be 95%, and for plus or minus 3 sigma, the percentage will be 99.7%. And there are some methodologies. First one is DMAIC, which stands for Define, Measure, Analysis, Improve and Control. Then the second one is DMADV, means Define, Measure, Analysis and Design, Verify. Then DMADOV stands for Design, Measure, Analysis, Design, Optimize and Verify. Then DSSS stands for Developing Six Sigma Software. Then CFPM stands for Cross-Function Process Mapping. Then after the lean manufacturing is there, it is an operational system that maximizes the value addition and eliminate the waste in the entire process, which is called the lean manufacturing. And it reduces the waste of first one is overproduction, then after inventory, then after motion, then waiting or dwell time, then after overprocessing, and the last one is transportation. Then it based on the Japanese method, which focused on the 3M, where first M stands for Muda, which is wastage. Then second one is M for Mura, which is stands for inconsistent. Then the last one is M for Muri, which is for unreasonableness or overburden. Then JIT stands for just-in-time process, which is pull system implemented first ever by Toyota company. Then after the last term is process capability. In that topic, first one is USL, which stands for upper specification limit. Then LSL, which stands for lower specification limit. And CPK stands for process capability index. Then PP stands for process performance and PPK stands for process performance index. Then the equations are there. First one is Cp is equal to USL minus LSL upon 6 into sigma. Then Cpk is equal to minimum of USL minus x bar upon 3 into sigma, or x bar minus LSL upon 3 into sigma. Then PP is equal to USL minus LSL upon 6, and PPK is equal to minimum of LSL minus mu upon 3 into sigma star, then mu minus LSL upon 3 into sigma star. Then mu stands for population mean, then sigma stands for sample standard deviation, and sigma star stands for population standard deviation. Here in the PP, you have to consider the value of sigma star. So this is all about the third chart of the IM and OR subject, in which we have considered the first one is the transportation problem, then after the plant layout, then after the job sequencing, and at the end the quality engineering is there. We have considered only the important formula for understanding the concepts. You can calculate some more examples based on the concept for your practice. And if you like this video, please do like and subscribe to the BS Academy channel. Hello and welcome to the BS Academy. We hope that your preparation is going well. So let's start the next video. Before that, if you are new to your academy, then please subscribe for the upcoming videos and the links for the short notes which are in description box. Let's begin with the first one, which is quality control. And this quality control, some concepts of this chapter we have discussed earlier in the third chart of IM and OR. So the link for that chart is given in the description box. Now let's continue from the third chart. Here the first topic is there are some 7 quality control tools are there. First one is histogram, then after the Pareto analysis, then after the cause and effect diagram, or you can say that the Ishikawa or fishbone diagram. Then fourth one is defect concentration diagram. Then fifth one is check sheet diagram. Then sixth one is scatter diagram, and seventh one is control chart. So from these 7 tools, the questions may be asked like which is not the tool for the quality control. So you have to remember these 7 tools. Then after, let's see one by one some diagrams here. First one is fishbone diagram, or you can say that the Ishikawa diagram or herringbone diagram or cause and effect diagram. It is used for identifying the possible causes for a problem. Then this diagram is created first ever by the Kaora Ishikawa. Then after, the next diagram is scatter diagram. It is similar to the line diagrams in which uses the dots to represent the individual pieces of data. And then this scatter diagram is first ever invented by the René Descartes. Then histogram is for accurate representation of the distribution of numerical data. And the first step is known as the bin or bucket. Then it is in the form of the bars, so it is also known as the bar chart. And the inventor of the diagram is Carl Pearson. Then control chart is there. In there 2 types are there. First one is variable continuous distribution and the second one is attributes. So in the variable continuous distribution there are 2 types. First one is X bar chart and the second one is R bar chart. Here you can say X bar chart is also as mean and R bar chart for range. Then X bar and R bar both the chart the normal distribution. Next one is attributes. In that 2 types are there. First one is P chart and the another is C chart. Here P for the proportion defective, or you can say that the fraction defective, and P chart follows the binomial distribution. Then C chart for count of defect or defect position distribution, and C chart follows the mu or exponential distribution. Then after, the next one is 5S technique, which is Japanese technique, and it results into the well organized workplace with complete and visual controls and order. And key step in this technique is workplace improvement. Then 5 steps are there. First one is sort, or you can say that the series. Then second one is set in order, or you can say that the seton. Then third one is shine for sisho. Then fourth one is standardize for shiketsu, and the fifth one is sustain for shitsuke. So you have to remember these 5 terms from the 5S technique. And talking about the reliability. It is the ability of the product to perform its main function for a specified period of time. And reliability in the series, for that, the equation of R is R system is equal to R1 into R2 into R3 into R4 into Rn. Then in the parallel, the equation will be like R system is equal to 1 minus in bracket 1 minus R into 1 minus R2 up to the 1 minus Rn. So from this equation you can note down the example here, and response time R of t is equal to e raised to minus lambda t and f of t is equal to 1 minus R of t, here f of t for the failure time. Then bathtub curve is also there. The diagram for the bathtub curve, you have to remember that in the first stage the warranty phase is there, in the second stage the catastrophic failure is occur, and in the third stage wear out failure is occur. Now the next topic is PPC, which means the production planning and control. Here first one is routing. For the loading, here it is the assignment of the work either to the individual or to the workstation without specifying the time of start of real product is called as the loading. And then after the balancing is there, it is the process of ensuring that the workload on different workstation remains same. Then scheduling, it take care of the time associated with the product at the different workstation, and PERT and CPM are common scheduling technique. Then in the dispatch, it is the execution function of PPC. This function actual production activity to start, concerned with a smooth introduction work on the shop floor. Basically, it is the execution of the ideas. MRP1 and MRP2 method are there. First one is MRP1, which is the method for the material requirement planning, and it is push system and dependent on the demand. The purpose of the MRP is to ensure that the materials are available at right quantity at right time so that finished product can be completed according to the master production schedule. And in the MRP2, the manufacturing resource planning is there. Then method for effective planning of all the resources of the manufacturing company, and it's not excessively a software function but the management of people skills requiring a dedication and to database accuracy and sufficient computer resources. VD analysis is there. V stands for vital item, E stands for essential item, and D stands for desirable item. Now the next topic is work study. The analysis of a job product for the purpose of finding the preferred method for doing it and also determining the standard time to perform. Then this job comes under the domain of work study, and work study is used for calculating the standard time. And advantages will be like it helps in a smooth production with minimum interruption. Then it helps to reduce the cost of the product by eliminating the waste and unnecessary operations. Then there are some modes are there. First one is O for operation, D for delay, arrow for transportation, and triangle for storage, or low triangle you can say that. Then square for the inspection. The symbols were mostly asked in the GATE examination. Then Gilbert has given total 18 symbols, and it calls the Thurbling's symbols, and it is used for the recording. Then 8 steps in the work study is there. First one is select, then record, then examine, then develop, then measure, then define, then install and maintain. Then types of chart are there. First one is operation chart, then flow process chart, then multiple activity chart. The last one is the SIMO chart. In the operation chart, the idea about the operation and the measure activity. Then in the flow process chart, the movement of the main material and equipment are recorded to examine. Then the third one is multiple activity chart, which is used for record activity of man and machine. And in the SIMO chart, the full form of SIMO will be like simultaneous motion chart. And this is the chart of the micro motion study, and it is used for short duration. Then movements are recorded against the time scale by using micrometer or wink meter, and one wink is equal to 1 by 2000 minute. Then two types of diagrams are there. First one is flow diagram and second one is string diagram. In the flow diagram, it shows the path of main material and equipment on a scale model of factory, and in the string diagram, strings are placed on a scale model of working area by which the frequent movement between the different points can be studied. Then density of strings is equal to idea about the frequency of movement, and examples are like ergonomic. Now the next one is work sampling. In this process, the person is continuously observing and he might become too sensitive or alert. Then data obtained by work sampling, PL is equal to Z into sigma P, then sigma P is equal to under root P into 1 minus P upon N, and P into L is equal to Z into under root P into 1 minus P upon N. Here P for observation function, L for level of accuracy, Z for factor related to the confidence level, or you can say that the CL. Then Z is equal to 1 for CL is equal to 68% or plus or minus 1 sigma. Then Z equal to 2 for CL is equal to 95% or plus or minus 2 sigma. Then Z equal to 3 for CL is or plus or minus 3 sigma. Then after the next topic is PMTS. Here PMTS stands for Predetermined Motion Time Standard, and in the PMTS each activity is divided in such a way that the size of each element is more than 0.04 minute. Stopwatch is not used because one time the questions were asked in the examination that if stopwatch is used in the PMTS or not. Further divided into three categories. First one is the method time measurement, then after the basic motion time study, and the third one is work factor system. Here the time study is not a part of the PMTS. Two examples are there for the above equations, in which you have to use the P into L is equal to Z into sigma P. Then you can find the value of N. Similarly, in the second example, you have to find the value of L. Here L for accuracy. Work measurement is there. It is the application of techniques designed to establish a standard time for skilled or qualified worker. And first one is MOS, which is for mean observation time. Then the second one is standard time is equal to NT plus percentage allowance of standard time, and MOT is equal to efficiency into MOT. Here one example which was asked in the 2005. You have to use the equation of NT is equal to RF into average. Here RF is equal to rating factor. Now this is the most important topic from the IM and OR subject for the GATE examination point of view, which is inventory control. First ever, the definition is there. Inventory is termed as stock on the hand at a given point of time, which may be held for the purpose of a later use or sale. Then total cost is equal to the purchase cost plus total inventory cost. Here in the inventory cost, there are three costs are there. First one is total holding cost, then total ordering cost, and the third one is back order cost or shortage cost. Then after the classification of inventory, four types are there. First one is transit or pipeline inventory, which cannot service while in transportation. Then the second one is safety or buffer stock, which reserves the stock came throughout the year and in critical demand. Then third one is seasonal inventory. The demand for this inventory item changes with the seasonal variation. Then fourth one is anticipation inventory. It built up due to some anticipation in demand in the future because of government policies changes. Here note that dependent demand calculated by MRP method and independent demand calculated by the forecasting methods. Then after review system is there two types of review system. First one is Q system and second one is P system. Now for the Q system, fixed order system is this, then reorder or level system and two bin system. Then safety stock is not required and A class items is there in the Q system and safety stock is 0 for the Q system. Then for the P system, fixed period system, then periodic review system, then safety stock is needed, then suitable for B and C class system. Then inventory review systems are there. In that first one is fixed order system and the second one is fixed period system. Here for the fixed order system, size of the order is fixed but the time of the order is variable, and in the fixed period system the time of the order is fixed and the size of the order is variable. Then ABC analysis, this is also very important. Here by Pareto principle or 80-20 rule is also used in the ABC analysis. The diagram you can see that in the inventory control technique, ABC analysis is mostly used. Here product A, which is more careful than accurate forecasting and frequent order of inventory. Then for product B, the moderate control. Then product C, less control, less accurate and bulk purchasing for the third type of system. Here the percentage of the A type is 10%, for B type 20% and for C type 70% is there. Here the diagram is for cost versus the percentage of inventory. From the diagram you can understand that for A type of products the percentage of inventory is 10% and the cost is around the 70%. For B type the inventory is 20% and cost is 70 to 90%, and for the C type the inventory is 70%. Then after the inventory model and calculation, first one is Wilson-Harris model or inventory without the shortage. Here TC for total cost, TIC for total inventory cost, TOC for total ordering cost or total procurement cost or total setup cost. Then THC for total holding cost or shortage cost. Then R for annual demand, Q for quality to be ordered. Then R by Q is equal to number of order in 1 year and Q by R is equal to time between two order in 1 year, or you can say that the cycle time in 1 year. Then CU is equal to unit cost or purchase cost. Then CO is equal to ordering cost per order. Then CH is equal to holding cost per unit per year, and LT for lead time, ROL for reorder level and Q average for average quantity, then T for cycle time. Here you can see that lead time is equal to the interval before which the order should be placed so that the material will be received on time, and inventory corresponding to lead time is equal to reorder level. By a similar triangle from the diagram you can see that Q by CT is equal to ROL by LT. This is the third equation which is useful. Then TPC is equal to CU into R. Then total procurement cost TOC is equal to C0 into R by Q. Then total holding cost, which is equal to CH into Q average. That means THC is equal to CH into Q by 2. Then TC is equal to CU into R plus CU into R by Q plus CH into Q by 2. then TIC is equal to C naught into R by Q plus CH into Q by 2. Then to minimize the total inventory cost, Q is equal to under root 2 into R into C naught by CH. Then TIC at Q at EOQ, which is equal to under root 2 into R into C naught into CH. Here at EOQ, remember that THC is equal to TOC. Here note that at EOQ, TIC is minimum, but TC may or may not be minimum, and optimum order quantity, it is the quantity at which the total cost is minimum. These are some equations based on which every year the examples may be asked in the GATE examination from the inventory control. So there are some examples are there. First one is for finding the EOQ. Then after for TIC at Q is equal to EOQ, you have to find the value of Q. In the third example, the percentage increase you have to find. Then for the fourth example, you have to find the value of ROL and use the equation of Q by ZT is equal to ROL by LT. Then for the fifth type, you have to find the value of demand, which is annual demand, in which you have to use the equation of EOQ is equal to under root 2 into R into C naught upon CH. So this is all about the fourth chart of the IM and OR subject, in which we have covered all the syllabus of the IM and OR subject. If you like this video, please do like and subscribe to the BS Academy and press the bell icon for the upcoming video. If it is useful for your other friends, then please share this video who is preparing for the GATE examination 2021.